Hi guys, we're working on 10B notes. These are examples 4 and 5, okay? And in these examples, we start to see how trig can really help us, okay? It says, given the figures below, find the missing variable, all right? So here we have a right triangle, and we only know the length of the diagonal, or the hypotenuse, and the measure of this angle, okay? So just like we have done on other trig problems, we're going to just start by writing out our SOHCAHTOA. And identifying what it is that we need to find. So we need to find x, okay, for all of these. And of course, now we'll go to our triangles and we'll label them. Across from the 90-degree angle, this little long diagonal, we always label with an H for hypotenuse. We know the value of the length of the hypotenuse. We know that theta now actually has a value. Here's the angle that we're interested in. This is what we have seen as theta, but now it's got an actual value assigned to it. But because this is the angle that's in question, the side touching that angle or next to that angle, we measure or we label as the adjacent side. And of course, adjacent means next to. It's next to that angle that's there. All the way across from this angle, not touching the angle, we label that side with an O. That's the opposite side. So we still always want to have our orientation in trig. Okay? Now, what we know from this diagram is that we have the measure of the hypotenuse, and the side we're interested in is the adjacent side. So let's go ahead and go up to our trig identities and ask ourselves which trig identity is only dealing with the hypotenuse in the adjacent side. And you can see that both of sine and tan also deal with the opposite side, which we are not going to use. We haven't assigned a variable to that side, and we don't have a value. So we only want cosine because it's dealing with the adjacent side and the hypotenuse. Okay? So we're going to use cosine of theta is equal to the adjacent side over the hypotenuse. And now let's plug in the information we have to that trig identity that we've decided to use. So cosine, well, we know what theta is. It's 60 degrees. And that is equal to the adjacent side, which in this example is x. We don't know the value of the adjacent side, but we have assigned a variable to it. And then it's over the hypotenuse measure, which is 11. And so now what we have is a problem where we can actually get a number for this and solve for x. And then that's going to give us the solution we want, the length of this missing side. And in order to do that, we need to go ahead into our graphing calculator, desmos.com, or if you have a graphing calculator at home, and we want to actually find what the cosine of 60 is. Now, of course, we need to be in degree modes, in degrees, and then we'll use our functions button to press cosine. It'll give us those parentheses, and then we will insert 60. That's the angle that we're interested in. And look, the cosine of 60 is actually 0.5 or 1/2, okay? So we'll go back to our problem set. Instead of writing cosine of 60 here. We found out what the value of that is. The value of that ends up being 0.5. And that still equals x over 11. Okay, now at this point, what we need to do is solve for x. Now, whenever x is on the top, you've got a number on bottom, we want to be able to get rid of that number on bottom. And since x is being divided by 11, now we need to multiply by 11. And we always do whatever we're doing in algebra to both sides. Okay, up 11, down 11, cancel. And that will give us 11 times 0.5 equals x. Okay? So, of course, when we multiply 11 times 0.5, and please just go ahead and feel free to use a basic calculator to do that. We're going to get 5.5, right? So 11 times 0.5 is going to give us 5.5. We can swap the sides here just so that our problem looks a little easier. X equals 5.5. And that is the value of the length of that side, the adjacent side that we currently have labeled as x. So now we know the value of x is 5.5. Okay, real quickly, let's go ahead and do triangle for number 5. Okay? Now, of course, we already have our SOHCAHTOA. And this, of course, is our angle that we're interested in. So we'll go ahead and label that triangle. That long diagonal opposite our 90-degree angle is our hypotenuse. That side touching the angle in question is the adjacent side. Adjacent, of course, meaning next to our angle, that angle in question. We've seen that labeled as theta. Now it's actually got a value. This side all the way across from the angle, we label that as the opposite side. Nothing is here on the adjacent side, not a variable or a length. And so we want to go and find a trig identity that's only dealing with the opposite side and the hypotenuse. And of course, that would be the sine. So that trig identity is the sine of theta is equal to the opposite side over the hypotenuse. And now what we'll do is we'll take the information from this triangle and plug it in to that trig identity. So we'll use sine, but now we're going to use 37 degrees. We can plug that into this variable here. The opposite side has a length of x, and the hypotenuse has a value of 10.3. Sorry about that phone ring, guys. Now, just like we did on example number 4, we're going to get a value for the sine of 37. Back to Desmos we go. Now we're trying to get the sine, so we want to put sine in, and then 37, that's our angle measure. And you can see here the sine of 37 is 0.60. We won't round up because that third number is a 1, so 4 or less. We'll just leave that 0 alone. 0.60 is the value for the sine of 37. 0.60. So we'll now say that sine of 37 is 0.60. And that's equal to x over 10.3 still. And just like we did on example number 4, we want to get this 10.3, we want to get rid of that 10.3 because we want to solve for x. Since 10.3 is on the bottom, or x is being divided by 10.3, we're going to multiply by 10.3. And of course, we always do that to both sides. Up 10.3 and down 10.3 cancel. And that leaves us with x equals, now we just want to multiply out that 10.3 times that 0.60. And that will give us 6.18. And that ends up being the value of the length of that side, 6.18. All right, thanks, guys. Appreciate all your work, and thanks for watching.